Here are some examples of how to use your KMap, your KMap, to simplify the Boolean expressions. We know if we're given a truth table of a function or the function in its sum of products form, or a complete sum of products form. So when I say complete sum of products form, that's that disjunctive normal form, which is unique because it uses all of the literals in each of those products. So it's also called the sum of minterms form. We can draw its KMap. So we'll look at some examples there. So again, note that the function does not need to be in the complete disjunctive normal form when you are trying to put it into the KMap, because when I do put it in the KMap, it will take care of all of the product terms that should have been in the disjunctive normal form. So it will be there once we place it in the KMap. What we do for a KMap, a KMap, is we place a 1 in each cell that corresponds to a minterm of the function. You could also place a dot if you would rather, but it just means that you're going to pick up that cell. So let's place a 1 in each cell that corresponds to a minterm of the function. One way to do this is if you're given the function's expression, here is a sum of products expression. I have the sum of some products here. Then wherever I see that combination occurring, I'm going to put a 1 in the cell. So where is the x times y cell? The x times y cell is here, so I'm going to put a 1. And then I look at the next one. I need the x complement y cell, and the x complement times y cell is this cell, so I put a 1. And then finally, we have x complement y complement. In the x complement y complement cell, I'm going to put a 1. So this is the setup so far of the this would be the KMap for the function. Now notice I could have written it as well as this way, where I put down the zeros and the ones. Let me put 0 and 1 since I did the complement first, then the complement, and then I just write which variable. This corresponds to the variable x on this side, and then this is the variable y on this side. So again, I would look at that and I would still say, okay, I need to have y complement, x complement, so this one would be that term, and then I would just finish out all the terms the same way. Or I could have been given a truth table. So if you're given the truth table for the function, then I can use that also to set up the KMap. And then what you would do is you would look at the minterms. So what would be the minterms here? Well, wherever you have a 1, so let me erase this part. Wherever I have a 1 for the function, how are you going to get a true value there? So if it was 0, 0, then I need to make those into 1s, and you're going to AND them because we're looking at the minterms here. So I'm going to do x complement and y complement. That's the combination when you do the ANDs. 1 and 1 will give you back 1. Here is a 1, so I need to do x, make that 0 into a 1, so that's going to be x complement. And then the y is already 1, so y. Now here is another 1, so I need to look and say, how do I get those all to be 1s? Well, they're already all 1s, so it's just going to be x, y. And then on the last row, I have 0, so I don't need to include that in a minterm. So these are going to be the sum, these are the minterms of the function that I've written. So together, I know the function has the sum of minterms, which is the sum of products of x complement y complement plus x complement y plus xy. So you are going to mark those the same way that you did earlier on the KMap. But we haven't minimized this yet. So we've done the KMap, now how do we minimize? Well, the way to minimize that expression, to simplify the expression, is to do the following. So the KMap is used to simplify the expression if we can do the following. You're going to group adjacent cells covering all minterms of the function So I do have to make sure I cover all the ones. So those are the ones, or if you place dots on the K-map, I need to make sure to cover all of them. But how are you going to cover them? How are you going to group them? So your book calls the grouping blocks, so you need to block them up. We're going to group only the ones. So the groups cannot include any zero cells. You want to make your groupings, which are also going to be known as prime implicants, as large as possible. Now, implicants are just those terms that appear in the function. So they're going to be our nice prime implicants is when we get these groupings that are made so that they simplify. So we're going to get this as large as possible, where the groups have size. So when you make these blocks, when you group them, they need to have powers of 2. Because remember when we were looking at the introduction to K-maps, since they had Hamming distance 1, they only differed in one literal. If I looked at adjacent cells, then you are going to get simplification, but that occurs in powers of 2. And again, in powers of 2, we saw that when we were dealing with our gray code as well. So they need to be rectangular in shape. They need to be powers of 2. And remember that the K-map actually has wraparound for adjacent cells. So we can actually, you're going to see some examples where we take our rectangles, but we have to visualize that they're having that torus shape on the K-map. So by grouping 2 to the n cells, we will eliminate n variables. So that means 2 adjacent cells will be able to eliminate 1 variable. And I showed that when we were doing the introduction to K-maps. In actually grouping 4, if you can, group 4 cells, you will eliminate 2 variables. If you can group 8, you'll eliminate 3 variables. So let's use the knowledge of this K-map so what's nice about the K-map is you can visualize, you can see the simplification of each group, and you don't have to use those Boolean laws and expressions, those properties that we had for simplification. But if you're not sure, so if you cannot see it right away, if you can't see the simplification, when in doubt, you can always write them out as a sum of terms and then simplify by the identities. And I'll just do that sometimes just to make sure that you understand if you can't see it right away. So here's an example. Simplify the Boolean function using a K-map. Okay, so let's just start from scratch. Remember, if you're given the truth table, you can come up with the midterms yourself. So you would come up with x complement and y complement. This one would be x complement y, and this one is just x, y. So you're going to have the sum of those midterms for your function f. So I would just locate them on the K-map. So on my K-map, I'm going to put down a 1, and then I have x complement y, and then I have x, y. Okay, and you can put a 0 here if you want to, because you know it is a truth table, but you don't have to write any zeros down. If you just want to leave them blank, that's fine, because we're not including those. So in our covering, what are we going to do? So this is called a grouping, a covering, or just call it the block. You're going to block it. I need to take powers of 2 of adjacent cells. So this needs to be rectangular shaped, and I cannot go over this 0 block. You don't want to go over that 0 block. So this would be a possibility. I could take this one. Okay, that's a nice large, I guess, relatively large grouping. I'm going to take that grouping. And what does that grouping reduce to? So if I just look at this grouping, can you see what that would be? The entire row here is used up. And what does that row correspond to? That entire row corresponds to x complement. So those two together should simplify to x complement. And again, like I said, if you're not sure, what that means is your K-map is telling you how to order your original sum of products so that you'll get simplification. So your K-map is telling you to take these two products, add them together, and you'll get simplification. But visually, I can see it should be x complement for the simplification. If you can't see that, what you're going to do is you're just going to go over down here. So this is, you try to avoid this. I mean, this K-map is supposed to be easy, so you don't have to do this. but just to show you, what you do is you say, well, x complement is in common. I factor it out. What do you have? Y complement plus y is 1. So you're reducing it down from 2 literals to 1. So you just get back x complement. Okay, so that's going to be x complement. Now, where else can I get a power of 2 rectangle as my grouping? So I haven't covered this one yet. So I don't want to just keep it by itself. You know, I don't want to just circle it by itself. I mean, that would be a power of 2, I guess, 2 to the 0 power, but I want to get it as large as possible. So what I'm going to do is I'm going to take this one. It's okay to have overlap. I'm going to take that as my next rectangle, my next grouping. So now what we end up with is can you see what you end up with? Well, that's the entire column which corresponds to which variable. The entire column corresponds to the y variable. So that should simplify to y. I'm just going to show you one time so we can get used to it. Let's see why that is true. So this is telling you, if you group x complement y and you add it with the xy, what do you get back? Well, y is in common, so I factor it to the back. X complement plus y is 1, so you end up with y. So that whole thing simplifies to y. So altogether, what we have is we have x complement plus y. So that is the simplified form. So this whole thing simplifies to x complement plus y. Okay, let's do another one. Let's simplify. Well, I wanted to use the algebra laws here just to show you separately, but I've already done them. So I kind of used the algebra laws here and here. And I was going to show you that it's a lot easier to use a KMap rather than the Boolean algebra laws to get back our simplification. So I can skip this step. I already used it. Okay, now here's an example. Let's simplify the Boolean expression using a KMap. This is not in complete disjunctive normal form, so it's not in the complete sum of products form, but it is a sum of products, okay? So I have sum of products everywhere, but you notice like this one is missing the variable z, this one is missing the variable x, so that's not complete sum of products form. It's not in the disjunctive normal form, but it's still a sum of products. So as long as you have a sum of products, then you can put it into a KMap. If you wanted to write it in the sum of products form now, I'll show you what you would do. So for example, you would take this one that's missing the complete term, and you would say, well, I know that y z complement is the same thing as 1 times y z complement. And then you need to add, well, not add, but you need to multiply by 1, but using the literal values that it's missing. So it's missing the x. So I do x plus x complement. Okay, that's the same, right? And then from there, you just distribute. So you would get x, y, z complement plus x complement y, z complement. So you see how you still have the y, z complement, but you have to account for the x and the x complement because they are going to be simplified to just this term. But if I replace this term with these two terms, see, that would be the correct complete sum of products for that expression. And then you could do the same thing for xy. It's just you would need a z there. So let me just do that. So you do the same thing and you do xy. And then for z, since it's not appearing there, it means it becomes a 1. But it would be the literal z plus z complement, and then you distribute like this. Okay, now that would all be in the complete sum of products form. But we can just do that on the KMap. So if I do that on the KMap, let me show you how that would work. Okay, I've cleared the page so I can show you how to do this on a KMap. So what we can do is, how many cells do I need in this KMap? Well, I have 3 variables. So I have 2, I need 2 to the 3rd, which is 8 cells in my KMap. And you can use zeros and ones if you want to, but I think I'll go ahead and just leave them. Leave those literals as is. And instead of putting x complement here, let me just put x, so I'll show you, you can just work it out this way. So it doesn't matter that order there. Now on top though, I do want to change one literal at a time. So this is our gray code, but I'm just using the variables here. So I want a y and a z, so it's your choice. Do you want to change the y to a y complement or the z to a z complement? Let me change the z to a z complement. Just change one at a time. At this point, again, you have a choice. Well, I already have used the z over there, so I'm going to have to change this to a y complement, z complement, and then I haven't used y complement z, so I just changed one literal at a time. And if you look, you need to mark a 1 in each cell that you have for the product. So the first product I see is x complement y complement z, so locate that cell. So the x complement y complement z cell, I'm going to mark a 1. And then I look at x, y complement, z complement, and I'm going to mark a 1. X, y complement, z complement. And you can use a dot if you rather, but we're supposed to use ones and zeros for a truth table. And then we have y, z complement. So notice this y, z complement, it was missing that x that I was talking about earlier. So you did see that it broke up into 2 products to get the complete sum of products form. But you can just do that on the KMap right now. So on the KMap, you just say, well, where are you going to get a y and a z complement back? Well, the y-z complement will come back in this entire column because that's the column for y-z complement. So you put a 1 in each of those positions. So you see how you're putting a position in the x, y, z complement, and in the x complement, y, z complement. Like we saw before, those were the 2 that you needed to add up to get back y, z complement. Now the next one is x complement, y, z. So I look for x complement, y, z, and I mark it with a 1. And then this one is the same thing. I have x, y. So where are you going to get back x, y? Well, we saw earlier, I worked it out there, but where are you going to get x and y together? So I look and I say, well, here's my x, and then I have a y and a y. So if you had ones and zeros, you would want to look for the ones on the x's and the ones on the y. So what do I have next? Well, that would be for any of these, where the other variable is z or, so see that other variable? The other variable is z or z complement. So it's those 2 corresponding cells. So I'm going to put a 1, so I'm going to put a 1 here and a 1 here, but there's already a 1 here. So maybe I'll just, I'll put a dot just to show you that I really did put something else there, but it was already a 1, so I don't have to worry about it again. Okay, so now that we have this set up, what I want to do is I want to use my procedure for covering all of these ones. So I want to group them, block them in as large as possible 2 to the n size rectangles. So the first thing I start with is I start with this nice big block here. So I want to group, I'll put a circle so you can see it. I want to group this part right here. So if I group those 4 cells together, it will reduce. And can you see what it's going to reduce to? So remember, if we take 4, you should be able to take out 2 of the literals. So you should be able to reduce that down by 2. Okay, what is that going to end up to be? And if you can't see it, then you can work it out, but I hope you can see this is what the K-map's all about. So what is it using? It's using which one as all ones here? Y. Y is going to be, when I say one, I'm just thinking back to the gray code of ones and zeros. Y is true here, Y is true here, but what happens with the other literals, the other variable Z? Well, Z is here, but then its complement is here. X is here, and then its complement is here. So that means those are going to simplify or reduce to a 1 so that you are left with just Y. So altogether, this is going to be Y. That's why the K-map is nice to look at. You can visualize what's going to happen. This is going to reduce to Y. All of that is Y. Okay, the next one, I need to get the next largest. So the next largest size here. How am I going to cover this one? Think about how to cover that one with as large as possible size 2 to the n rectangle. Well, I can use the adjacent one next to it to make size 2. So size 2 is better than just leaving just a size 1. Now, remember, I'm not covering any of the zeros, any of the empty spots. So you could have put zeros here if you wanted to, but I just like to leave them empty, and I won't use them. Okay, so here I've circled these two. So what does that grouping mean? So again, the K-map's telling you how to order things so that you will get simplification. So can you look at that to figure it out now? So if I look at those two, don't forget the X over here, that still corresponds with an X. So I have an X in both of those. So I know I'm going to have an X here. And then I have a Y and a Y complement. So that means the Y and the Y complement are going to combine to reduce to a 1, but you still are going to be left with a Z complement since it's in both. So this whole thing is XZ complement. And if you're not sure about that, then you want to look at the laws of Boolean algebra. But remember that cell, what does the cell represent? The cell represents X, Y, Z complement, and then this cell represents X, Y complement, Z complement, and it will reduce to X, Z complement. Okay, we still need to cover this one down here. Now I could just leave that as Y complement Z, but that wouldn't be, I could leave this as X complement Y complement Z, and if I did that, it wouldn't be reduced completely. So let me just show you for a minute. If I left this and I just grouped this one by itself, which I don't want to do, but if I just did that, it would be X complement Y complement Z, but it's not going to be reduced completely to what I'd like to show you. So what I'm going to do is take the largest rectangle. It's a wraparound. So what that means is this one, so we use this symbol to mean that you're going to wrap it around to this other cell here. Okay, so I'm wrapping it around to this one to make a size 2 rectangle. So what is that going to reduce to? So this is the part where if you can't see it, you might want to write it down, but you see that X complement is in both of those cells and Z is in both of those cells, but the Y and the Y complement are going to reduce down and out to 1. So you're just going to be left with X complement, that's in common, and then what else is in common is the Z. Okay, and if you couldn't see that, then that's going to be this part right here. So if you can't see that one, what you should do is just write it out. It's going to be X complement, Y complement Z, and you're adding it with that other cell on the other side, the wraparound. And then if you notice, you can factor out an X complement Z, and then the Y complement plus the Y reduce out to a 1. So you're left with X complement and Z and 1, which is X complement Z. Okay, but we're trying not to do that work so that we can end up with this representation. Add these up, and you're finished. So the simplified form is Y plus X Z complement plus X complement Z. Here's another example. Let's use a KMap to give a minimal expansion or expression for this sum of products expression. So I have this sum of products expression. It's actually a complete sum of products expression because every term that I see here involves each of those variables or its complement. So let's take this and form a KMap. So how many cells are you going to have? You have 3 variables. So again, I'm going to have 2 to the third, which is 8 cells. This time, how about when we do our KMap? Let me get my 8 cells. Let me use the zeros and ones this time. So I'll put A over here, and then the other 2 here, B, C, B times C. And let's use the 0 and a 1, and then maybe I'll do that gray code 0, 0, 0, then a 1, then a 1, 1, 1, 0. So as you notice here, I need to look to see which ones are going to be in my expression. So I have A complement, B complement, C complement. So the cell that is A complement, B complement, C complement is 0 represents A complement. If you want to write it down at the same time, I guess I could, just to show you that represents A complement. This represents A. This 0, 0 here represents B complement, C complement. So this would be B complement, C complement. This would be B complement, C. This is BC, since they're both ones. And this is BC complement. Okay, but that's what that means. And I'm going to put a 1 down at A complement, B complement, C complement. So I have A complement, 0, so all zeros. It's this one. Then I need to have A complement, B complement, C. A complement, B, C. A complement, B, C complement. You probably already see some simplification, but we're almost there. A times B complement times C complement. So I'm over here at A, and I need B complement, C complement. And then A, B, C complement, and that's it. So that's our truth table here put into a KMap where every adjacent cell differs by only 1 literal. The Hamming distance is 1. Now you can put zeros. Just remember not to cover any zeros or just leave them blank, and I'm only going to cover the ones. So as large as possible, let's get our 2 to the power n rectangles to cover these. So my groupings. So I look and I see that I need to cover this 1. So how can I cover this 1? Possible is I could cover it with itself, but that's not large. 2 to the 0 is 1. That would be a size 2 to the n rectangle. I could cover it with this rectangle. That's better, 2 to the first, but there's an even better choice. The largest possible would be 1, 2, 3. See, that's size 4, so size 4 works. When you do your groupings, you need to have the sizes of powers of 2, and that is a power of 2. You're not going to have any odd sizes for your rectangle here. So I have 4 that I've grouped together, and what does that reduce to? Remember, if you have 4, you're going to take out 2. It's going to eliminate 2 of your literals. And what are you going to be left with in this case? Well, this whole row corresponds to A complement. So this whole thing simplifies to A complement. If I were to combine those 4 products together, add those 4 products together, it would give me A complement. And you can look up there to see that. You probably saw it already. As you were going down the list, you said, oh, well, that's just A complement if I were to add all those up. Okay, so this is just a way to organize those thoughts visually, though. Now the next one, I need to cover this one. Again, I could cover it with itself, but that's not big enough. I could cover it with, say, just this one and this one. That's better, that's size 2, but that's not even big enough. So what is the biggest rectangle that you can form of powers of 2? Do you see it? I can take this side, remember they wrap around, so this is 2 so far, but then I combine it with these 2, so now I have size 4. So that's a size 4 rectangle. that I can combine. And what would that reduce to? Do you see what it's going to reduce to? So it uses A complement and A, so you know that's going to take out the A. Those are going to reduce out. What else? It uses the C complement. Well, actually, it uses the B complement and the B. See, it has the opposite B complement on this side and B on this side. So that means it's going to reduce out the B's because you're going to get B complement plus B, which is 1. And then what are you going to be left with? In both of those columns, it's a C complement in both of those columns. So it's not the opposite literal, it's just C complement. So that whole thing that I have grouped here, that's going to reduce, those two are going to reduce to just C complement. So together, what have you reduced this really long expression to? You've reduced it all the way down to A complement plus C complement. Here on this example, let's use a KMap to simplify, which means minimize the expression. So for the output, let's minimize this output. If you look at this first term, or yeah, this is the only term that's not a product. So I wanted to start with a sum of products, and this is not a product. But you are taking A plus B plus C complement. So by De Morgan's law, we can form a sum of products. So the sum of products, it doesn't have to be a complete sum of products. We just need to have the products listed. So A plus B plus C complement, by De Morgan's law, you're able to write that as the product of complements. So this term becomes A complement, B complement, C complement. So I'm going to start with this. This is not a complete sum of products, but the reason this does not have a C or a C complement, and this one does not have a B or a B complement. But again, it is a sum of products. If you wanted to write it as a complete sum of products, you could do it at this step, or you can just wait for your KMap. So if we can just wait for our KMap, I'm going to go ahead and sketch this out. We have 3 variables. Okay, I know I have 3 variables, that input of 3 variables. So we're going to have 2 to the third, 8 cells. And let's do zeros and ones this time. So I'm going to put my, and it doesn't matter, you know, I could put C here. I think I was usually putting A, but let me put C over here, and I'm going to put A times B up here. So we're going to do our gray code. I'm going to do 0, 0, 0, 1, 1, 1, just change one bit at a time going across, and then I'm going to do 0, 1. That's my choice there. Remember what the zeros represent. They represent the complement, and the order here I did is A, B. So that means A complement, B complement. This one, A complement B. This would be A, B. So usually we don't write these out. I just keep writing them out just so you can get used to it. This one would be C complement, and this would be C. Okay, so I have to look at what I have here for my implicants. Those are just what do you see here. So I see in these sum of products A complement, B complement, C complement. So I need to locate where is A complement, B complement, C complement. So everything needs to be complemented, and that would be this cell. And then I look for A complement B. Okay, see how that's missing the other variable term there. So what that means is you need to fill it out for C and for the C complement cell. So I need to do A complement B, C, as well as A complement B, C complement. So where is that A complement B? Well, that's represented by this whole column. So see how that goes with the C complement and with the C? I mean, both of those. And now I do A, B, C complement. So A, B, and C complement would be this cell. And then we need to do A and C. So A and C, that's missing. That's not a complete product there, but where would A and C be located? So I need all the A's. So I need them to be true. So when I look for A's to be true, I'm looking at these ones. And then I also need to have C to be true. So it would be down here. So together, that gives me those lower two cells. So now that we've figured out what we have in our K-map, the rest are zeros, so you can write the zeros or not. We need to cover up the ones. So if I cover up the ones in the largest possible rectangular size 2 to the n groupings, so I can see this one right away. So I'm going to take this one, it's size 4, so that's good. That means I'm going to be able to eliminate 2 of the variables there. So what does that correspond to? You have A complement, B, C complement, then you have A complement, B, C. All the rest, you see that you have the complements opposite on the B's and the C's, but the B remains the same. So this is all going to reduce to B. Okay, and so we got rid of 2 of the literals, and we're down to just B. Now, what's the largest group that you can form with the rest? Okay, so we were working something out like this before, so what do I have to do is I'm not going to take this as a single cell. That wouldn't be the largest. I'm going to take not 3 because I don't want odd. I need powers of 2. So it's going to be these cells right here. So what will those cells reduce to? So I have A complement on both of those. The B complement and the B, so I'm looking at this B complement and that B, they're opposite, so they're going to reduce out, but I still have the C complement, so it's going to be A complement, C complement. Okay, and then finally I need to cover this one, so don't cover the one by itself. What we're going to do is make it size 2 to the 1, which is 2. And what will that reduce to? So you notice you have the B and B complement, so that's going to reduce out so that you're going to be left with the A, see that's the same, and then you have the C. So it would be A, C. So altogether this function, f, reduces to, and the order here won't matter, I'm just adding up A complement, C complement, B, and I'm adding up A and C. Okay, here is another example. Let's say you're given the Carnot map of a function. Let's simplify the function to the fewest literals. So I've put my zeros and ones for my gray code. Let's see if we can get the simplification for this one. So as you start, you look to see what you can group. So on this one, you can group, and I think we did this one earlier, the groupings. Let's see if you remember. What does this go to? So this is a good review. So as you go across, you could start with a K-map, and you'll have to come up with what does it reduce to. So what does that whole row, and I chose this because it is size of base 2 to the second, so that would be size 4. It's the A complement column. So that whole thing reduces to A complement. Okay, then what would be your other choice? Remember how we got the largest choice? To cover the rest of the ones, we actually took this wraparound, and together, what did those reduce to? Can we think back? So you see, you have in those cells, we're having A complement and the A together, so we're going to have A complement plus A, that when I add. So that's going to reduce out. And then what else do we have? B with B complement, so we're going to be adding those out. So you're just left with, yeah, C complement. C complement is in common there. So you're ending up with C complement, this whole thing. So let me write down the answer then. So all together, we end up with F reduces to the A complement plus the C complement. And in this example, let's minimize the output expression that's given using a K-map. So we're going to look at how many variables we have here. We have 4 variables that are being considered, X, Y, UV as well as their complements. Now this is in a sum of products form. It's just not in a complete sum of products form because of that first term and that last term. They only have 3 of the variables in or their complements in there. So what I'm going to do is, you could write out the complete forms, but we'll just put them in the KMap. So I have 2 to the power 4 variables, so 2 to the 4th, which I need 16 cells. When I form my KMap, you can use the zeros and the ones like we did before when we were talking about the gray code, but I am going to just write these out. Okay, so I'm just going to do maybe X and Y here. I'm going to do X and Y so just change one literal at a time. So now it's time to change the X to an X complement. And now it's time to leave the X complement and change the Y complement to a Y. Then here I'll do the U and V complement. Then change the first one to a U complement. And then finally U complement V. Okay, so now that I have everything set up, let's talk about this first one. So this first one, I'm going to have to put a 1 in 2 cells since it's missing the U. Then you'll have to put a 1 for the U as well as the U complement. So I need X and Y, so I'm over here. And then the V occurs in U and V as well as, whoops, not that one. The V also occurs, as I've written it here, U complement V. So I'm going to put a 1 in each of those. Okay, so the next thing I have to do, so now that one's done. Okay, let me actually just go to this last one. Let's do this one. I need X complement and Y and V. So for this one, I look at X complement Y. So you're here in this row. And then for V, where does V happen to occur here? It's going to be those two, because as you notice, the U is missing. So I'm going to have to take care of the U and V, U complement and V. So I'm going to put a 1 in each of those. Now find the rest of the cells. Those were the only ones that were different because it wasn't in the complete expression, so I had 2 for each of those. And then the rest of them will just occur, let's see, the X and Y complement, U, V complement. And then X, Y complement, U complement, V complement. Okay, then I'm at X complement, Y complement, U, V complement. And then X complement, Y complement, U complement, and that's supposed to be a V complement. Okay, so I finished that part. Let me change that to a V complement here. So here's our KMap, and so what are we going to do with this KMap? With our KMap, we have to look at which ones to group. So I think it's obvious one of the largest ways to cover the ones here in the middle is I'm just going to circle this part, and that's going to be size 2 to the 2nd, so that's acceptable. I think that's the largest. And what is that going to reduce to? So can you think about what that block is going to reduce to? I notice that it involves X as well as X complement, so I know that's going to reduce out the X variable, but it has the Y complement here in both of them, so the Y complement is going to stay. Okay, but over here, then what else? The V complement is the same, so that's going to stay. And which one is going to sum out? The U plus the U complement, that's going to go away. So that whole thing that's circled in the middle is just represented, or is, Y complement, V complement. And now I have to think about what's the largest grouping for the last part. Okay, so for the last part, what's the largest grouping? So I do have wraparound. So if I think about it, these cells are connected in my torus, in my donut shape. So altogether, I could have, I'm just going to try to change the color to show you that this is going to match up with this, but also they're matching here. So this is actually size 4. So it's not like I'm doing 2 size 2s. I'm taking all of these at one time. I'm going to do a size 4. So what are you going to end up with? So can you see what you're going to end up with? So I have X here with Y, X and Y, but here I have X complement Y. So it looks like I'm going to be left with a Y. So over here, I'll just draw an arrow for all of those. I'll just draw maybe 4 arrows just to show you those 4 parts. This is going to end up to be, and which one were we picking on? The Y. We said the Y was going to be left. Okay, and then look at the columns at this point. So in the columns, I notice it's U, V, then I have U complement V. So the U's are going to add out to a 1, so you're left with V. So this is just going to be Y, V. So all together, so this part we simplified, this part we simplified. So all together, the answer is Y, V plus Y complement, V complement.